Good morning, people. I have a bit of laryngitis, so I sound a little funky today, but hey. So let's talk about this, time. In my model, time is a compact dimension. Time is one single Planck second in size, and that's all there is. There's right now, as things are happening. The past happened, but it's gone, and there's no getting it back because we had to take all the components of what was the past to create the present out of. I mean, a tree is here now. The mass is here in the present. If it existed in the past as well, that means that mass has to be carried through an infinity of time, which creates this crazy bulk, which is actually problematic. And we're going to talk about how compact time actually explains some things. And I have time. This is compact. This is like the moment of time. And let's say this is one place in the universe, and there's another place in the universe. They have the same time. Time of computation, because in the Wolfram model or the stuff that Faye Dowker is doing, computational models of the universe, the actual only present, and if you talk to them about it, time is a compact dimension. It is the moment of computation, and it's constantly evolving. So states are ever changing. This is the moment that you have to change a state within one Planck second, one rotation of any given particle. So let's say we have time and it's just sitting there and you're in deep space. This is how we can also use this to demonstrate manifestive charge. Let's see. Okay, so there we go. A layer of photons, 90 degrees to us. This is time. And there we are. We're rotating on time. Because we're in plane of time, this would be like deep space with basically the wiggling of my stick is the quantum flux. Basically, very little is going on. There's no energy because everything is in time. Everything's in plane. Now, I start to go out of plane. And now all of a sudden, notice we have an inflow to the top section of the plane and an outflow from the bottom of the section of the plane. An outflow from one place is an inflow to the other, preserving conservation at all points. Consider an electron, the yellow part, in our space, in our time frame. Oh. It has a reciprocal positron on the other side of time. Electrons are half spin. They do one orbit as an electron on one side of time and an orbit as positron on the other side of time. Then an orbit as electron, orbit as positron, orbit as electron, orbit as positron. This is why electron half spin. This is why it takes two spins. This is not, there is a reason for it. It is not an arbitrary thing. Nothing is arbitrary in the universe. Logic rules. So this explains electron half spin and positron half spin. Should you be able to find a positron? So they get used up pretty fast. And then interestingly, let's consider a photon, which is half electron and half positron. You can rip them apart and become two charged components. It's not really, it's a little plain fast and loose, but look at that. Oh, a photon which propagates sits on time and therefore doesn't, the charge is distributed both sides of time. There's an inflow and there's an outflow, but they're consecutive. This is how it propagates, because it will propagate into the vacuum that's created by the electron. And this is why it would have no spin, because it's evenly on both sides of time, not like an electron or positron. And then more complicated pieces like neutrons are composites, so that would be a more complicated construction that I can't really demonstrate here very easily. But the fundamental is that if time is a compact dimension, this explains electron half spin. It explains photon, why a photon, and why a photon can be its own anti. Just a thought.